Hi, welcome back. In the previous video, we learned about the event loop and explored the concept that comprises the event-driven architecture in Node.js. This video will teach us about single-threaded in Node.js, what it means, and how Node.js handles multiple connection requests. Now, despite being single-threaded, Node.js can handle multiple connections simultaneously through its event-driven architecture and synchronous programming techniques. Why is Node.js single-threaded? We know that dividing tasks between multiple threads makes it faster. But then, why Node.js is single-threaded and claims itself faster? This happens because of two important concepts that will be explained later. But first, let's understand how multi-threading works. If you have a multi-core processor machine, then your task will be divided into these cores. Allocating tasks to any core is taken care of by the operating system, and tasks will get allocated to which core depending on the core's availability. Let's take a look at this diagram to help us understand better. So assuming you have a system or a machine that is dual core, you notice that when you have 4 tasks, it will be shared amongst these different cores. So tasks 1 and 2 will be handled by core 1, and then tasks 3 and 4 will be handled by core 2. Okay, so these tasks, like I said before, can be shared amongst these different cores depending on the availability of the cores. Now, suppose you have a dual-core processor. The dual-core name itself suggests that the processor has 2 cores. Now, when you run your programming project or task, which is having 4 tasks, if you write a multi-threaded program, then your 2 tasks will be allocated to 1 core of the processor, and 2 tasks will ideally get the other core of the processor. There are already known problems with multi-threaded systems, which are beyond this course's scope. You can read more about this in our operating system for backend engineers, link in the resources tab of this video. Now let's explore how Node.js is able to serve multiple requests with a single-threaded architecture. 1, we have event-driven concurrency. Node.js event-driven concurrency model enables it to handle thousands of concurrent connections efficiently. Instead of spawning a new thread for each incoming connection, Node.js uses a single-threaded event loop to manage multiple connections concurrently. This lightweight approach minimizes context switching overhead and memory consumption, making Node.js suitable for building high-scalable server-side applications. Lastly, we have worker threads. While Node.js primarily operates on a single-threaded event loop, it also supports worker threads through libuv, allowing developers to leverage multi-threaded processing for CPU-intensive tasks. By offloading CPU-bound operations to worker threads, Node.js can utilize multiple CPU cores effectively without sacrificing the benefits of event-driven architecture. This hybrid approach enables Node.js to achieve high concurrency and efficient CPU utilization, making it a versatile platform for various applications. In this video, we have learned different ways that Node.js enables single-threaded, and also how it is able to handle multiple connections through the use of event-driven concurrency and worker threads. We have also seen how tasks are being divided amongst multiple threaded systems. Example, if you have a dual-core machine, how tasks are going to be divided amongst these different cores that you have. So in the next video, we are going to start looking at non-blocking I/O. So see you in the next video.